Hey everyone, welcome to This Explainer. If you're focused on maximizing the potential of AI in software development, well, you are definitely in the right place. Today we're looking at a genuinely incredible tool straight from the engineers at Cloudflare, the security audit skill. And I want to be clear right off the bat, this isn't just some basic script. It's a multi-phase coding agent skill that literally turns your standard AI into an independent, relentless security auditor. Because let's face it, manual security audits, they are notoriously time-consuming. They take massive amounts of human brain power, and frankly, they can be a real bottleneck in fast-paced development cycles. But imagine if you could flip the script. What if your coding agent could systematically hack your own codebase to secure it long before it ever reaches production? That is the exact problem this tool solves. It's an AI orchestrator built specifically to hunt down and validate real vulnerabilities in your code. Okay, let's dive into this and look at our roadmap for today. 1. Your AI security auditor. 2. The 6-phase pipeline. 3. Principles of real impact. And 4. Running your first audit. Starting off with Section 1, your AI security auditor, turning coding agents into vulnerability hunters. Now, this tool is actually the single repo starting point that seeded Cloudflare's massive fleet-wide vulnerability discovery harness. And it's vital to understand its core identity. It's not just about sending a clever prompt to a language model. It's about orchestration. This skill manages multiple parallel AI agents to execute a highly complex, structured audit. It basically acts like a project manager spinning up different AI instances to tackle different parts of your codebase simultaneously, all with one singular goal: finding exploitable vulnerabilities that actually matter. Moving to Section 2, the 6-phase pipeline, step-by-step through the AI audit. Now, what's really interesting about this is the exact blueprint of how the simulated attack actually happens. The sheer rigor of the methodology is fantastic. It's not just a quick, noisy scan. It is a rigorous 6-phase pipeline: recon, hunt, validate, report, structured output, and verification. This entire pipeline is designed not just to find flaws, but to ruthlessly eliminate false positives so your dev team isn't out there chasing ghosts. Let's break these phases down. Phase 1 is reconnaissance. So before any hacking even begins, parallel research agents are deployed to map out the application's architecture. They identify trust boundaries, they map all of the input surfaces. Essentially, they're mapping out all the doors and windows of your application. And this foundational research gets compiled into a document called architecture.md, which acts as the master map for the upcoming attack. With that map in hand, we enter Phase 2, the hunt. This is where general agents aggressively attack the codebase from multiple specific angles. They're testing for injection flaws, access control issues, cryptography weaknesses, business logic errors, and even really complex chained attacks. They also throw in a wildcard prompt for some out-of-the-box thinking. And what's amazing here is that if an agent finds a thread, it can autonomously spawn sub-agents to dig even deeper into that specific potential vulnerability. But what happens when an agent actually finds something? And this brilliantly illustrates my absolute favorite part of the whole system. Phase 3, validate. We get a built-in red team versus blue team dynamic. The original agent that found the vulnerability is on side A, but on side B, the orchestrator spins up a completely separate adversarial agent whose sole job is to try and disprove the finding. This adversarial validation is the secret weapon to kill false positives before a human developer ever sees them. Once a vulnerability actually survives that intense validation, the tool moves right into phases 4 and 5, report and structured output. It generates highly readable markdown reports for humans, which includes detailed traces for anything medium severity or higher. But crucially, it also writes a machine-readable JSON file. This JSON data is then strictly validated against a predefined schema using a zero-dependency Node.js script called validatefindings.cjs, ensuring the output integrates perfectly with your other automated tools. Finally, the whole pipeline wraps up with Phase 6, independent verification. The orchestrator brings in completely fresh AI agents that haven't been involved in any of the previous steps. Their one and only job is to look at the structured JSON output and verify every single factual claim against the actual underlying source code. It is the ultimate sanity check to make absolutely sure the report matches reality. Let's move on to Section 3, principles of real impact. Designing for low noise and high value. So, having seen how the tool works, we need to look at the strict rules that separate this from your standard, super noisy vulnerability scanners. So, the crucial point is the golden rule. Only report what you can exploit. If an AI agent comes back and says, well, an attacker could theoretically do this, nope, this system rejects it.
Every single finding requires a concrete, provable attack scenario. If it cannot be exploited, it simply does not make the cut. And that flows right into the tool's broader design principles. Severity, for instance, is strictly calculated as likelihood multiplied by impact. It's not just a deviation from some best practice checklist. Furthermore, defense and depth gaps are explicitly not treated as vulnerabilities. Like, if your app is missing security layer B, but security layer A completely prevents the attack anyway, the tool just logs it as a hardening note, not a critical alert. This drastically reduces the noise for your team. Another really core principle is how the tool scales through something called additive runs. Testing actually shows that a single run of this tool only finds about half of the total vulnerabilities hidden in a codebase. So the system is designed to be run multiple times. During these additive runs, the scale reads prior JSON reports, skips the issues it already knows about, and actively targets entirely new code paths to build a cumulative, comprehensive defense over time.
All right, rounding it out with Section 4, running your first audit, putting the skill into practice. Let's move to and see how this builds into your actual workflow. How do you deploy this? Surprisingly, it is an incredibly user-friendly experience. You don't need to write complex configurations at all. You literally just start your coding agent in the codebase or point it at your repository and ask it to perform a security audit. The skill listens for natural language triggers like find vulnerabilities or pen test the code, and it activates the entire orchestration automatically. However, there are a few technical prerequisites to keep in mind here. Because this is a really complex orchestrator, your underlying AI model must support tool use. And crucially, it absolutely must support parallel subagents for that 6-phase pipeline to function properly. You're also going to need Node.js installed on your system to run that Phase 5 schema validation script we talked about. By transforming a standard coding agent into a rigorous, self-correcting security auditor, this skill represents a massive leap in how we approach secure development. So I want to leave you with this final thought to chew on today. As you integrate more AI into your workflow, are your AI agents just writing code, or are they actively securing it? I highly recommend checking out the Cloudflare Security Audit Skills source repository to learn more and see this powerful orchestrator in action for yourself. Thanks for joining me for this explainer, and happy auditing.